Hello friends, thank you for watching this video. I am Mohamad and today we're going to be discussing something really important when it comes to building any .NET application, which is error handling. And in today's video we're going to be discussing global error handling and how we can implement it within our web API. We're going to go through the process of creating a web API and basically creating a simple model connected to a database, and then we're going to be basically creating a global exception handling middleware. We're going to understand why do we want to build it there and how we want and why do we want to make it as a middleware, and then we're going to see how we can actually implement different types of exceptions, and then we can see how it will be able to catch those exceptions when anything happens within either in our controller, our database, and our services, so on and so forth. So this video is going to be quite interesting one because basically it will build up on how we can actually create much more sustainable and durable web APIs and .NET application. If you like this video, please like, share and subscribe. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon, as well as buying me a coffee. Now grab your cup of coffee and let's get started. So let us discuss our plan of work for today. First of all, what we're going to be doing is we're going to be creating an application. We're going to be installing some packages. We're going to be implementing a simple CRUD where we're going to be able to add, create, delete, and update. And then from there, we're going to be implementing the global exception handling. So basically, when we add it, it's going to be implemented directly on our controller, and basically subsequently any controller that we create or any implementation that we're going to be creating after that. And we're going to be seeing different types of exceptions. So not found, unauthenticated, unhandled errors, so on and so forth. It's going to be multiple types that we're going to be covering. And this is really important to see how we can actually implement a single middleware for exception handling, basically global exception handling. And we can basically cover a wide range of exceptions that the system might generate. And we're going to be seeing how we can actually implement our own custom exception if we need to as well. So let's get started first by creating our application. So inside our terminal here, first of all, we need to make sure that we have .NET 6 installed, we have the SDK available and ready for us. Once we have that, let's navigate to our folders and let's go to work, learning, .NET, and let's create a new basically folder. I think there's a error handling folder, and let's create a new application, .NET new, and it's going to be a web API, and we're going to give it a name of global error handling, or we could call it the global error app, something like that. And it's gonna take a few seconds to be completed, and it has been already completed. Once that is done, let's navigate to it, and once let's see what's inside. And let's do a .NET build just to make sure that everything is building as it should be. And we can see here that build has been succeeded. And once we have that, let's basically open it in Visual Studio Code. Perfect. So now it's open in Visual Studio Code. Let's zoom in a bit. Let's make sure that this is big enough. I think it needs a bit more. Okay, I think that should be fine. Okay. So first things first, once we have our application ready, let's remove this, we don't need it. Let's open our terminal here, and let's make this a bit smaller. And I'm just going to do a .NET build again, just to make sure that everything is running. Oh, great. So once we have created our application and we have opened in Visual Studio Code, the next step is for us to install some packages. And for the sake of this video, we're going to be utilizing with our CRUD Postgres database. If you don't know how to set it up, or you don't know how to connect it to our application, and you want to delve more deep into .NET and Postgres, I'm going to link a video here somewhere where you'll be able actually to go see a much more detailed video on how we can actually accomplish that. But for now, we're going to just assume that you already have a database set up. It doesn't have to be Postgres. Any database server that you might have, it will work. It could be SQL, MySQL, Postgres, Mongo, any even non-SQL database will work. But for the simplicity of this video, and so we're not making it a couple of hours long, we're going to be utilizing Postgres. So the first package that we want to install is basically the entity framework core. So it's going to be .NET add package Microsoft.entity framework core, And let's install this. We can see this will take a couple of seconds to be completed. Great. The next one is going to be as well .NET add package Microsoft.entity framework core.design. Perfect. Let's clear this up so we have a better view. The next one is going to be Postgres, so it's going to be .NET add package npsql.entity framework core.postgres. Let's see, npsql, oh, I forgot the G, it's npgsql. Let's try this. Perfect. And the last one is going to be entity framework tools. So let's add this. So .NET add package Microsoft.entity framework core.tools. Okay, great. So once we have done all of that, now we can verify this by going to our global error app.cs proj, and we can see here that we have all of our application that has all of our Nuget packages has been installed successfully, which is exactly what we need. So just to make sure that everything is running, it's always good to always try to do a .NET build. So it's going to be .NET build, and we can see here build succeeded. Perfect. So the next step for us is we need to start creating our model. And this model is going to be responsible for utilizing entity framework so we can migrate to the database. And once we have done all of that and we have it inside our database, the next step for us is going to be basically building some kind of a database application DbContext, and then we're going to be creating the controller, and then we're going to be implementing the global error handling. So let's create a new folder, and it's going to be called models. And inside our models, because it's a sample application and because Formula 1 is the best sport, so we're going to be creating a driver's model. So let's create a new class, and we're going to call it driver.cs. And let's make this .NET 6. Perfect. And this is going to be a very simple model. It's going to be public int id. Or actually, let's do it like this. Int ID, int string name. So it's gonna be driver name, and we're just gonna put the last one is driver number. Very simple. So once we have created this, basically now that we have created our model, the next step is for us is to create our application DbContext, and from there basically we can start implementing the migration, connecting everything that we need. So let's go into our root folder, and then let's create a new folder. We'll call it data, and inside this data we're going to create a new class, and we're going to call it app DbContext. And basically, let us implement this. And from here, what we're going to be doing is basically we're going to be setting up our application DbContext. So it's going to inherit from the DbContext class. Now let's fix those references. And now what we need to do is implement the constructor. And this constructor here, basically, it's going to utilize the DbContext options, and then it's going to take app DbContext, and we're just going to call it contact options, and we're going to pass it to the base one. As simple as that. If you want to learn more about how we can actually implement DbContext, how we can create unit of work, or basically how you utilize entity framework core within .NET, I'm going to link a video here where you can actually go and basically explore that. But for now, I'm just assuming you already know all of that, so I'm just skimming over it. but I highly recommend to go watch that video if you're not really familiar with how we can actually create all of this and why we are doing it like this. So once we have done all of that, the next step basically we're gonna be just assigning the the drivers table that we have created. So we're gonna say public, let's put it outside. Let's make this like this. Let's make it as a single line, and then here let's make it public dbset driver driver, and we're gonna call it drivers, and it's gonna be get and set. Very simple. And let's fix those references. Perfect. So now we have our DbContext ready. So once we have set up our DbContext, we can see here that we are actually progressing fairly well within our application. So basically now we have a model, we have a DbContext. Next is we need to actually create our connection string, connect it to our application runtime, maybe do a migration, and then from there we can actually start implementing our controllers. And so let's take it step by step. So once we have done that, the next step is let's open our app settings, and inside our app settings what we need to do is we need to add our connection strings, where basically we're telling our .NET application how it can connect to our database. So from here it's gonna be, we're gonna call it sample db connection, and basically this is gonna be a user ID equal, I already know all of this, my password is gonna be equal to 1 2 3 4 5 6 7 8, and we're gonna put server is equal to localhost, and from here basically we need to specify the port which is gonna be equal to 5432, and then once we have that we need to put the database, and the database is going to be equal to sample db1, and lastly we're going to put integrated security, and this is always going to be true. And then lastly, once we have done that, we're going to put pulling equal true. Great. So once we have done all of that and we were able to actually set up that our connection string, the next step is we need to go to Program.cs, and inside our Program.cs we need to actually inject our application DbContext with the connection string here. Very simple. builder.services.add entity framework core PSQL, and then here we're gonna basically connect our add DbContext. And here basically we need to specify what is our application DbContext, and in this case going to be app DbContext. I think let's fix those references. Okay, great. And now we need to specify the options. And we're gonna see here, gonna put options dot use npg SQL. I think this also we're gonna, let's make this capital, and let's fix those references. And from here we're gonna basically utilize the builder.configuration.get connection string, and then we're gonna just pass a sample connection, and that should be it. Let's make sure we call it sample connection, sample db connection. Okay, it's a good thing we checked, and let's put this here. And now if we do a .NET build, let's see what's gonna happen. Perfect, our application is building, and this is exactly what we wanted. Great. So now that we have our program ready, basically we have updated it with the latest configuration so we can be able to connect to our database. Next step, let's do a .NET build, and then once we make sure that everything is running from there, what we can do is we can implement the first migration and making sure that our tables are being reflected into the database. And then what we're going to be doing is we're going to be creating some database services where we're able to actually add, update, delete entities to our database. And there what we're going to be doing also is we're going to making sure that we have basically did the application DbContext injection to those services, and then we're going to be implementing the global error handling. So let's do right now .NET build. We can see that our application is building successfully, and then we're going to put .NET EF migrations add, and because this is going to be the first one, what we're going to be doing is we're going to put initial underscore migration, and this should take a few seconds, but basically in essence once this is completed, it's going to create the first migration for us. And then what we're going to be doing is we're going to put .NET EF database update, and this should update our database with the latest changes. Perfect. Now if we open our database browser, dbbeaver, and basically let us just close these, we don't need these, and let's open our data, let's connect to our database, Postgres, next, let's leave all of those, let's see the database name, I think it was called, I can't remember the name, sample, okay, global errors, so let's put this as a database name. The username was Mohamad, and the password was 1234567 and let's do a test connection, perfect, and now finish. Now if I should open this and take a look at my database, and I should be able to see inside that I have my tables, and I see here the driver table, perfect. So now that I make sure that my database has been created successfully, the table has been migrated there, the next step is for me to create the services that we're going to be able to communicate with my database. So inside my root directory, what I'm going to be doing is I'm going to be creating a new folder, and this folder I'm going to be calling it services, and it's going to be very simple. I'm going to create first an interface, and then I'm going to create a implementation of that interface. So it's going to be driver service, the first interface, the only interface actually, and here let us just let's make it like this, and basically in essence within this driver interface we're going to be basically implementing the CRUD operation. So we're going to put public, let's make it back, okay, public task, what's the first one, let's put enumerable driver, and we're gonna get drivers, and let's fix those references, perfect. The next one is gonna be public task driver, and let's put a question mark because in case it's null we want to return a null result, and here we're gonna put get driver by ID, and it's gonna take an int as an ID. Then we're gonna put public, excuse me, task, we're gonna return a driver after adding it, so it's gonna be add driver. I'm gonna say out the word driver right now. And then we're gonna put another public task, another driver, and we're gonna say update driver. It's gonna take a driver. And lastly we're gonna put another public task boolean, and this is gonna be simply for deleting the user at the end. So delete driver and driver. Very simple. Oh sorry, it's gonna be here int ID. Okay, great. Now that we have created our interface, the next step is for us to basically create our service, which is going to be implementing this interface and implementing the connection to our database. So inside the services, I'm going to put the new class. I'm just going to call it a driver service, and it's going to be a very simple class, actually a very simple implementation, but let's see it in action. We're just going to implement the iDriver interface. And here, let's just do simple implementation of this. Implement interface. Perfect. And the first things first is we need to actually connect our application DbContext into the service so we're able to actually utilize it. So we're gonna put the prop, let's put public, read only app DbContext underscore DbContext. And let's fix this references here. Okay, great. Now we need to create our constructor. And we're going to inject this into the constructor. So we're going to say app DbContext DbContext. And here is going to be DbContext equal DbContext. So this is very simple. So the reason that we're doing it like this is to make it easy for us to directly inject our DbContext into our application. There's another way where what we can actually do is we can actually inject this inside our, actually create a unit of work, and basically once we create our unit of work, we can directly inject all of the service that we want there. That's a bit more complicated that we're trying to achieve here. For the simplicity sake of this video, what we're doing is we're directly injecting this inside our service itself. But I highly consider I highly suggest if you actually want to build a long-lasting or basically a much more complicated application to directly utilize the unit of work, is it basically it makes the separation of concern much more better, and it will allow you to have much more flexibility around your DbContext and basically your database structure. And for this reason, for the simplicity's sake, we're directly injecting it here. But again, if you're actually creating a much more bigger, I highly suggest unit of work. If you don't really know anything about unit of work, I'm gonna link it here somewhere where you can actually watch a full video how you can actually implement unit of work when it comes to creating a web application or a .NET application, .NET Core web application. So now that we have injected our DbContext, the thing is here, the first one we're gonna be doing is adding the driver. And then adding the driver is going to be quite simple. So let's check it. It's going to be var result equal await underscore DbContext.drivers.add async. And we're going to pass the driver, if I can spell today, driver. And then what we're going to be doing is we're going to put awake underscore DbContext.saveChanges async. And then what we're going to be doing is var actually return result.entity. Very simple, straight to the point. Now for the delete driver, let's do this one first because we can reutilize inside the delete of the driver. We're going to put return await underscore DbContext.drivers.first or default. And here we're just going to do a matching on the ID itself. So if the ID matches, we'll find it. If not, it does not exist. And why it's not happy? Let's see. Oh, okay. I need to make this async. And yes, I don't understand why VS Code does this type sometimes does not work, so we just need to add it manually using Microsoft Entity Framework Core. So let's add it here using Microsoft Entity Framework Core, and now this should work. Yeah, it's happy. So let's do the delete here. So all we need to do is var found, or actually var result driver. Let's put it like this, get by ID. We're just gonna pass the ID here, and let's make sure that it has been awaited. And once we have done that, just put basically underscore DbContext dot remove, and we're gonna remove the driver. And it's telling us that maybe is it remove async? Nope, remove. And then what we're going to be doing is we're going to put DbContext.saveChanges async, and let's make this as an awaitable. And then all we need to do is put driver return driver not equal to null. So if it's not equal to null, we're gonna return true. It means that it has been deleted successfully, else we're gonna be returning false. And then let's see this one, get drivers. So that's also very simple. What we're gonna be doing is we're gonna put return await underscore DbContext dot drivers dot to list async. Very simple. And the last one is going to be updating driver, and this is also going to be a bit simple. So for result equal underscore, actually let's utilize that again, await get by ID, and here we're gonna pass, actually it's gonna be confusing things, DbContext and drivers dot update, and we're gonna pass the driver very simply. Is there an update async? Nope. So without an await, and here we're gonna put await underscore DbContext to save changes async, and then all we need to do is just return result dot entity, and that should be it. So right now let's do a .NET build just to make sure that all of the code that we have added, it did not break anything, it did not change anything, or basically we did not miss anything that might basically break our application. So once we have done all of that, now it's time for us to actually inject this service inside our Program.cs. So let's go here and basically inside, before we can actually do the builder.build, let's inject this, and we're gonna put let's put this all the way at the back, builder.services.add scoped. And the reason what we're doing here is basically we're injecting this service in a scoped way. So for every single request which is coming in, we're creating a new instance of this service rather than having it as a singleton or a single version of this service which is available for us. If you don't really know anything about dependency injection, don't worry, I have another video which I'll be linking again here somewhere, which we're going to be covering dependency injection in much more detail and the difference between scope, transient, and singleton. So let's put driver service, and we're gonna put a driver service, and let's just fix those references. Perfect. Let's do another .NET build just to make sure that everything is working as it should be. Okay, great. So once we have done that, the next step is gonna be very nice, and we're gonna be creating our controller. And basically let's create a new class, and we're gonna just call the drivers controller. Visual Studio Code, actually it caused headaches, to be honest. Drivers controller. Like, it is something that belongs to Microsoft. Why they don't have better support for .NET application, I don't know. Anyways, that's a topic for a completely different day. So let's copy this and let's make this a bit better. So this first is gonna be called set weather forecast. It's gonna be called drivers controller. We don't need this. We definitely don't need this. So now we have like a very simple empty controller called drivers. Oh, and we don't need this. So this one here needs to be updated. Okay. Perfect. So now that we have basically a very simple and empty controller that basically does not do, don't need this. Which basically does not do anything yet. What we need to do is, first of all, we need to inject our service, create some of the endpoints that we want, and then we can work on creating our global error handling. So first of all, let's inject our service. So it's gonna be private, read only, driver service. I'm gonna call the driver service. And let's add this. And then here what we're going to be doing is I'm going to just inject it into my constructor. So driver service, we're going to call it a driver service, and then let's just pass it here. So driver service equal driver service. Perfect. So the first thing first is let's just create a simple endpoint, and this endpoint will allow us basically to interact with our application and basically either add, delete, update. So we're just gonna build it as we go. We're not gonna do all of them right now. Just create one by one, and we're just gonna see how it works. Excuse me. So let's try it here. So the first one is gonna be the simplest one. So it's gonna be HTTP GET, and we're gonna call it driver list. Basically get all of the list to get all of the drivers. And for this one, it's going to be public async task action result. And basically here we're just going to call it drivers list. It's not going to take anything, it's not going to process anything, it's just going to basically go to the database, check all of the drivers that we have and return them back to us. We're going to put var let's just select the return. Oops. For driver list drivers actually equal await underscore driver service dot get drivers. I'm gonna do basically put return okay and return the drivers. It's very simple. And let's add another one, which is basically gonna allow us to add a driver, and then let's do the get driver.id. So first of all, let's do the add a driver. It's gonna be HTTP post, and we're gonna call it add driver. It's gonna be public async task action result driver, and we're just gonna pass the driver as a driver. Very simple. Okay, so let's see this. Perfect. At least this works within Visual Studio Code. So now let's do a very simple var result equal await driver services add driver and then here what we can do is return okay, oops, okay, and return result. Yep, that should be fine. And lastly, let's get driver by ID, which is gonna be an header HTTP GET, and we're gonna call this get driver by ID, and it's gonna be public async task action result, and we'll say get driver by ID, and it's gonna be of type int, and we're gonna passing the int because this is we're gonna be passing the ID because that's what we're gonna be doing the matching on. And first of all, let's do var driver equal what are we gonna doing here? We're gonna put await driver service get driver.id, passing the ID. That should be it. And then we're gonna say if driver equal to null. So that's one aspect that we're gonna be doing. We're gonna say basically return not found. We're gonna update this to a different thing down the road, but that for now, let's return not found. And right now what we're gonna be doing else, we're just gonna be returning okay, and we're gonna return the driver. So this is a very simple implementation of an API endpoint, and basically with the integration to our Postgres database and be creating an application DbContext. And we can see here that we have the different layers. So we have basically the database layer, we have the service layer, and we have the controller layer. And basically what we want to do here is we want to basically create a single error handling mechanism. So in case there's a failure within any of those layers, if it's a database failure, if it is a service failure, if it is a controller handling failure, any of those, our global exception will be able to capture it. So we don't really have to redo the work on all of these layers. So now that we have like a moderate CRUD, 3 input CRUD, we still have to do the update, but that's fine. Now it basically is time to create our global error handlers. And those global error handlers, basically we're gonna be creating it as a service where we can be able to inject it inside our middlewares. And basically once we are able to inject it into our middlewares, our application will be able to actually recognize if there's something going wrong. And once the application is able to recognize that something is going wrong and something is not right, it will be able to capture it and basically process it based on that error type. And that's going to be the main goal. So once we have done all of that, now let's go back to our root directory. And inside the root directory of our application, what we're going to be doing is I'm going to be creating a new folder. And this folder, we're going to call it exceptions. And inside the exceptions folder, I'm going to be creating a class. Basically, I'm going to be creating different classes. And basically all of these classes, they're going to be representing different types of error that I might have. And there's a lot of different errors. For now, I'm just going to be covering some of the few basics one, but you can basically expand it as much as you want. And the first one, we're going to put request exception. And let's fix this. And basically here, it's just going to be simply inheriting from the exception class. And within the constructor, all it's going to be doing is accepting a string message. And it needs to pass the space message. Message. So basically, we're just inheriting from the exception global class. We're creating our own bad request exception. And we're building on top of that. So that's the first one. The second one is going to be the not found. So let's create a new class. And I'm going to say the key not found exception. Again, similar to what we have done before. We need to inherit from the exception class. And then here I'm going to create the constructor, and it's going to request string message, and it's going to pass this to the base class as a message. Great. So now I have done that. The next one, I'm going to create let's create a new class, and this class we're going to call it as simply as not found exception. And this not found exception is not going to be any different. So let's take this. I'm going to put exception, and similarly to what we have done previously, it's going to be string message passed to the base message, and that's it. Perfect. And now the next one is going to be not implemented exception. So new class, not implemented exception, not implemented exception. Okay, that's correct. And then here is going to be exception. Again, I'm going to put here string message equal base message. Let's fix this. Oops. And lastly, let's add, I'm going to put unauthorized exception, access exception. Okay, let's fix this. And here exception, and then lastly what we need to do is put string message and pass it to the base. Okay, so now what we have done is basically we created 5 of the most generic exception types, which is gonna be the bad request, key not found exception, not implemented, and unauthorized access exception. So these are going to be the most common 5 exceptions that you might face when you're building with an API or any web application. So right now, although we have these 5 exceptions, but we are not able to actually tie them together in any way. So the next step for us is basically to have a middleware. And basically this middleware is going to be able to intercept any exception which is might be popping up. And based on the exception type, we're going to basically do some implementations. So in order for us to do that, what we're going to be doing is we need to go back to the root directory, and inside the root directory here we're going to be creating a new folder, and basically this folder we're going to be calling it configurations. And inside this configurations folder we're going to be creating the main global exception handler. So let's create a new class, and this is going to be called global exception handling middleware. Such a long name, but that is completely fine. So let's make this here, let's close this, let's add the semicolon here, and perfect. So once we have done that, the next step for us here is to start to update this class so it will actually be able to process and act like a service within our middleware. So let's see how we can do that. So first things first is we need to make a private, not protected, private read only request delegate, and we're gonna call it next, and then we're gonna create a constructor, and this constructor basically is gonna handle the request delegate, next, and it's gonna be something equal underscore next equal to next. So far so simple. All we did is basically added the request delegate, because this is where from the application pipeline that the .NET will do when the application is running. Is going to go through that pipeline, and basically that pipeline is basically called the request delegate, where we're passing it from one middleware to another. Again, different video to go which cover this in much more detail. So, but this is just a quick overview. So once that the request delegate jumps from one middleware to another, and the reason we're doing it like this, every middleware that we need to create should be able to handle that delegate request, and should be able to pass it from receive it and pass it. So the way to receive it is inside the constructor, and at the end we can see how we can pass it to the next middleware. And remember, middleware's order is very, very important. So once we have done that, the next step is we need to have an invoke. So the invoke here, basically it will emphasize that the middleware is going to be running, and basically it's going to execute some stuff, and then it will pass the middleware the action to the next middleware once the middleware is finished working. Our current middleware has finished working. So public async task is going to be invoke, invoke, and here what we're going to be doing is we're going to take the HTTP context, and we're just going to call it context, and from here we're just going to put try and a catch, exception EX, and here we're gonna say await handle exception async context EX. And this method right now that we have created doesn't exist. So what we're doing here is we're going through the normal middleware that process that we have. Inside this, in case there's an execution failure, so let's say any of our 3 pillars has failed, either the database, the service, or the controller have failed, we have a try catch here. So once it all pops up all the way back up and it fails there, what we're doing is we're catching that error. Once we catch that error, what's basically very simple, we are passing that error that we have caught into the handle exceptions async method that we're going to be creating. And once that method has captured the handle exception async, it's going to be basically in essence verified or not verified. It's going to be identified of what type of error it is. Once it has been identified what type of error it is, we're going to be basically processing it based on that and basically return the response back to the user that we need to. So here it's going to be very simple. It's going to be await underscore next, and we're just going to pass the context. So this is really important for us to understand. So the request is coming in, and basically once it comes in to our application, it will go into the controller, then it go to the service, and it go to the database. So let's say there's a failure on the service level, something went wrong there and an exception has been thrown. So it will pop up to the controller, then from the controller it will pop up to the middleware that has invoked it. And so inside that middleware, what we're having here is we're gonna having the catch request, once we're catching it, we're passing it into the right method, which is going to be handle exceptions async method, and then from there what we're doing is basically we are processing it. So to make this a bit simpler, let me just open this and 1 second, new private window, and let's open it here. Let's go to the favorite website that everyone likes, draw.io. And this should be quite simple. So the draw.io, let's open it up. Okay, let's use it within Chrome. I don't know why Firefox is not happy with it. So, and let's zoom in. Let's put on device, create a new diagram, and let's see what type of diagram do we want to create. It should be fairly simple. Let's do a basic one, and we'll call this global errors. Global error. Global. So I'm gonna call it like this inside the downloads folder. Okay, save. So basically what we're gonna see if this is also being visible on the, without being, okay, perfect. So let's zoom in more. Okay. So what let us explain what's gonna happen here so we can actually able to understand it in a much more visualized way. So this is the user. The user is here, and basically the user did a request. User. So the user did the request, and this request has basically flown from the user all the way to our application. Let's make it like this, and for simplicity's sake I'm gonna say this is my application. I'm just gonna put a line here, and it means this has reached my application, just for simplicity's sake. So the user made a request and the request has came here. So what's gonna happen? So the first thing is there's gonna be a lot of checks, HTTP checks, that's gonna run in the background. So basically the request is gonna come in, it's gonna hit my application is verified, it's gonna be a valid request. So let's say here this is gonna be the HTTP handler. So once that HTTP handler has been actually received and we can see that it has been accepted, so the next step is it's going to go through the middlewares, for example, and we're going to have different middlewares which is going to be doing different stuff. So right now we're just going to be focusing on the middleware that we're going to be having. So since we said middleware is going to run one after another, and basically they're going to be running as it's going to be like running one inside of another. So it's going to be like a layered approach. So this middleware has executed, it's going to call the next one. It has been executed, it's going to call the next one. It has been executed, it's going to call the next one. And then once it finishes, it's going to go back through the same ladder of the middleware that has been implemented. So let's make this a bit bigger. And let's imagine this is the first middleware that we're going to be doing. And I'm just going to call this, put here, I'm going to put this like this is the first middleware. And the next one, and let's make this a different color so we're actually able to identify them. So this is going to be the first middleware, for example, the HTTP handler. I'm going to have another middleware here, which is going to be running inside of this one. And this second middleware, for example, it could be, let's make this a different color, and let's copy this, and let's copy this. This is going to be middleware number 2. And this middleware number 2, for example, it can be the logs, I don't know, something like that. So that middleware is now running. The next step for us is going to be the middleware that we have created, which is going to be the global exception handling. So let's take this and let's make this here. And let's make this also a bit bigger. And let's make this also a different color. And let's copy this. And here could be, this is our new middleware, which is going to be the global exception handling. And let's take this and let's make this like this. This is going to be middleware number 3. And let's add one more so we can actually see the full scope of this. So let's add this here. And let's make, let's make this a bit bigger. And let's make this a bit like this. And we'll call this middleware, let's say, middleware 4. I don't know, something that it's doing it in the background, we don't really know. The main reason that we want to implement this here so we can see the flow of it. So 4. So this has, the request had hit here the HTTP handler, which should be fine. But once it has reached the HTTP handler, what happened? It's gonna be basically going from one aspect, or basically one middleware to another in a layered approach. So let me see if I can find like a nice arrow where we can see jumping in. I think I saw it one time, but if I'm not able to find it, that's fine. I think that's it, yeah. So what happened here? Okay, let's make this, okay. So the middleware hit this one, and then once that middleware hit the first one here, let's make the middleware or the jump in a nice red color. So after it jump into this one, it will jump into the second one. Once it jumps into the second one, it will jump into the third one. And then once that has been completed, so this is going to be the first step, 1, 2, and 3. Once it has been completed, right now it's going to start jumping back. So let's put it this way, and let's make it out. So it's going to be jumping outside. So it's going to be jumping outside the application, something like that. Apologies, my drawing skills are not really up to the standard, but it's going to be something around like that. And then all the way out. So we can see here, so let's make this here as a, see a different color. Let's make it this as a orangey color. No, it's not really. Okay, let's make it this. Brown. Brown should be fine. Let's make this a brown. And let's make this a brown again. So basically here what we're seeing is the middleware is actually coming in one by one, and then basically it's exiting one by one. And basically once we have, let's say there's an error inside any of this middleware 4 or anything. So once there's an action, an error happening anywhere, it's gonna pop up to the middleware is gonna catch it, and then it's gonna process it. And this is really important for us to understand, because it's a global exception handling, so it's gonna happen everywhere that we want. So I think it's a better approach is to change this from here to here and make this the logs stud, just to make sure it's a really high level. But basically this is going to be the idea. The request is going to come in, it's going to hit the first middleware, it's going to go to the exception handler, it's going to go to all of the other middlewares. Once that's completed, it's going to continue jumping back up. So once that has been completed, we're going to be able to actually see a much better, or basically have a better handling of our application. So now if we go back here, let us implement this method in order for us to actually see how we are able to handle those exceptions. So it's going to be a very simple way to handle this. All we need to do is gonna create a new method, and we're gonna basically see how we can actually implement those error handling. So first things first, we're gonna be creating a private static. It's gonna be task, because it's gonna be an async request, and we're gonna put called handle exception async, and this is gonna take an HTTP context, We're gonna call it context, and it's gonna take the exception itself, EX. And basically here what we're doing is gonna put HTTP status code, because this is what we're gonna be returning back to the user base in case there's any error. We're gonna put status, and let us add those references. Let's add them one by one. Is this the same name? Let's make sure. Okay. So the next one is gonna be var stack trace, because this is really important for us to actually be able to get all of the error information and pass it back to the user. String.empty, and then we're gonna put string message. Just call it message as empty as well. And then we're gonna put var exception type. So basically here what we're doing is, we're taking the exception that we have and we're trying to get an exception type. Exception type equal ex dot get type. And now basically what I did here is I just utilized whatever exception it has been sent back to me in order for me to get the type. And lastly I'm gonna put if there's a typo here, let's fix it. If exception type equal type of not found exception. So let us fix those references and let us understand what's going on here. So because I got the exception type, what I'm doing is I'm matching it to the exceptions that I have added previously here, which is going to be the exceptions, the bad request, so on and so forth. Because what I'm doing is I'm getting the type, I'm matching it, and based on that I'm going to be doing some analysis. So right now, for example, or some processing, sorry. So let's see how we can do that. So because I matched it to this, I can say messages equal to say exception.message, or it's going to be ex.message. And then I'm going to say the status of this, the HTTP status. I'm going to say HTTP status code dot, let's say bad request. And then what I can say, the stack trace equal exception ex dot stack trace. So here we can see that I have much more control of what type of information I want to relay back to the user in case there is any errors. And right now I'm taking a much more generic approach and general approach. When it's a real live web application, you don't really want to return your internal errors back to the user. You need to handle it much more better. But for now, for simplicity's sake, we're just returning the request as it is. But let's say you're in a production environment and you have someone, let's say an endpoint which developers can consume. It's much more better to send back a much more valid error where the user will be able to understand, rather than just sending a stack trace of your API, where basically we will give first the internal of how the application works, which you shouldn't do that, because basically it will give back more information and makes it easier for hackers to or basically any suspicious behavior to take advantage of your API, and you don't really want that. And the second way is to make it much more user friendly, so it will be much more easier for people to interact with and basically build API integration with. So that's the first one. Let's do another one. We're gonna put else if exception type equal type of not found exception, and here let's say we're gonna put message equal ex.message, and we're gonna say status equal HTTP status code dot not found, and we're gonna put stack trace equal exception ex.stack trace. And let's see why it's not happy, this one here. Okay, so let's fix all of them and then I'll fix this error. So let me do them for all. So this one for the not found, now let's say not implemented exceptions, and for the not implemented it could be here for not implemented, and this message could be the same. Yeah, let's see what else. another else. So another not implemented. I think we have not found. We already added the not found. So not found added. So we have, okay, we have bad request. Okay, so we have bad request, we have the not found, we have the not implemented, and let's add the bad request, not found, not implemented. Now let's see key not found. And we can, for example, for the key not found, we can just make it as not found as well. And for the unauthorized, let's make it as unauthorized. Okay. And lastly, in case our error does not match any of this, we just put an else. And let's take this. And this one here is gonna be, let's say, the internal server error. And let's leave the same as before. And here, once we all done all of that, we're gonna put var exception result equal JSON serializer. Let's fix those references. Dot serialize new error, error equal message. And here, for example, we can see that here we are actually defining whatever we want to return back to the user. So basically we're returning here a JSON which illustrates the error, the message, the status code, and the stack trace. And we're just going to return here the stack trace. And once that is done, all we need to do is just attach the HTTP response. So context dot response dot content type equal application forward slash JSON and context dot response dot status code, whatever it has been come from before. So we're just going to make it as end, and we're just going to return the status that has been available for us. And lastly, we just need to pass back the request. So return context dot write dot response, actually dot write as write async, and then we're gonna put exception results. And this is exactly what we want. So let's do a quick recap of what we have done here. Oh, we still did not fix this, and this is really important. So let's go all the way up, and let's add them here. So we're gonna put a using statement. So let's delete this, delete this, delete this, delete this, and put them here. Using key not found exception equal global error app dot exceptions dot key not found exceptions. So let's do them for the not implemented. Actually, let's do it from here. Not implemented exception. And let's do it as well for the unauthorized access exceptions. Let's take this, and here, let's see. Why it's still not happy? Because for an if statement, it needs to be a double equal, and this shows you how early it is for me when I started recording this video, and I haven't really woken up yet. Okay, so I think that should be fine now. Let's do a .NET build. Perfect, it's building. So let us do a quick recap of what have happened here. So basically, in essence, we created a middleware, and then basically we added a try catch whenever the middleware is executing. So in case there's an error here happening anywhere, Inside that middleware, what we're doing is we are able to catch it, and then once it catches it, we have created a method called handle exception async, and that method basically takes that error and analyze it. And here basically we created the 3 variables that we're going to be populating, and we got first the error, the exception type, so we can match it to one of the exceptions that we have created. Again, these are all generic exceptions. There's much more you can actually implement yourself. And what we're doing here is we're just doing matching if equal to that, do this, if equal to that, do this, if equal to that, do this. So for example, if it's a bad request, we're returning a bad request. For example, if it's not found, not found, not implemented, so on and so forth. And unauthorized, and if there's anything which is not covered, we're just returning an else with a generic internal server error message. And then here what we're doing is we are basically serializing the request that we have, the error with a stack trace, and then we're returning it as JSON type to the user with the HTTP status request of whatever the error was, and then basically we're writing it back, so we're stopping the request and we're sending it back to the user. So that's in essence. So now that we have created our middleware, the next step for us is we need somewhere where we can actually inject it into our Program.cs, and that's going to be also quite simple to do. So all we need to do is inside our configuration here, we're going to be creating a new class, and this class we're going to call it application builder extension, and this one is going to be fairly straightforward. All we need is we're going to create the static class so we're able to inject our middleware. So let's see how that's going to work. So first of all, this class needs to be static, and then here all we need to do is just put public static application builder add application. Actually, we can say add global error handling, and we're gonna put this application builder, because basically what we're doing here is we're taking the application builder that we're currently having and then we are passing it back. So we're taking it, injecting it, and then we're passing it back. So we're gonna put this as application builder. Builder. And once we have done all of that, the next step for us is just do a simple lambda function, which is going to be application builder dot use middleware, and we're going to pass our global error handler, global handling exception middleware, and all we need to do is make it like this. Perfect. So now that once we have done all of that, the last step is we need to go to the Program.cs, and inside our Program.cs, let's add it here. I'm gonna put app dot, what did we call it? Where is it? It's called add global error handler. So let's add this here, and let's fix those references. And that's it. And now let's do .NET build. Perfect, the application is building. And now let's run it and see what happens. So .NET run. It's gonna ask me for my password. Perfect, now let's go back to that web browser here and let's go to localhost 5268. So it's gonna be localhost 5268. Why? Okay, let's remove HTTPS redirection. I don't really want this right now. Let's run this again. It was localhost 5268. Was it? What was it? Yeah, localhost 5268 / swagger / index.html. Perfect. So let's zoom in a bit. And basically here we can see that we have our very simple API endpoint. And basically we can see here that it has everything that we need. So the 3 endpoints that we have, Let's delete this, let's keep it. So what I'm gonna be doing right now is I'm just gonna try to get a normal, this is an ad. I'm gonna try to get a normal driver ID. So remember, this is an empty database, does not contain anything. So right now, if I just type 2, it should give me not found. It's gonna give me 404, error not found, and basically it gave me this generic error type. So let's go back to our web API, to our controller, excuse me, and let's open it up. So what I'm gonna be doing here is I'm gonna update this. So let's comment this out. So it's just gonna be throw new not found exception, and we're gonna and we're gonna pass the message that we want. Let's fix those references first. And I'm gonna say here that the ID is an invalid ID, for example, or something like that. So let's stop this and let's run this again. It can ask no. So right now, if I come here, let's look at the result. So this is the original error that I received before I implemented my custom error handler. So right now, if I do execute, we can see that the error has been updated. So first of all, we can see that the error that I have created has been passed, which is gonna be the ID is not a valid ID. And then here what happened as well is I was able to get all of the stack trace that I needed in order for me to help debug the issue. So again, the stack trace is not something that you want to send back to your, if developers are consuming it. It's only good when you are developing your application. But again, this is a sample application, so we can build it however we want. So that's one aspect. So let's try another type of exception handling. So let's say what I want to do, what else did we implement? So not found bad request. So let's say here, let's say, let's make this as or for example, let's just for experimentation, I'm gonna throw new bad request exception. I'm gonna pass this is not a valid ID. And basically, we're just experimenting here. So that's different types of error. So the not found one, we can see we got a 404 and we got this error here. And now if I just throw a bad request, let's execute this, we can see that the 404 converted to a 400. The error has been updated to a bad request. The message for bad request has been updated, and we can see I got the stack trace. And from this, you can see how powerful the global exception handling is, where basically you have a single middleware handling all of the exceptions that you might have, having full control of how you are sending the response back to the user, having full control of how you are actually processing. If you want to add logs, custom logs to your exception, you can add. If you want to, for example, have custom logic to handle any exceptions, you can also add it there. If, for example, you want to have much better performance, you can do it from here. And there's a lot more stuff that we can actually cover, but the main item here is exceptions handling inside .NET 6. Utilizing global exception is a much more better way for us to handle it on a much more better scale and much more bigger scale when it comes to our application. So for this, let's do just a quick recap of what we have covered in today's video. So first thing is we have basically created a new web API, and then we basically created like models, and then we created an application DbContext, and then basically what we did is we have connected it to a database. So all of this just like a simple setup, and then what we did is we have created a global exception. We have created different exceptions. We created a global exception handler middleware. We basically injected into our program, and then once we have injected into our program, what we have done is basically we have just tested it out inside our controller to see how it works, and basically we have experimented with it. And again, I really hope you were able to see the power of global exception handling, because basically this will make your code much more structured and much more durable. So if you like this video, please like, share, and subscribe. It will really help the channel. And if you have any questions, please put them in the comments down below, and have a great day.